Hi everyone, we see you again. So today the lesson should be the tutorial lah. So tutorial 3.4. So hopefully you are finished your tutorial. Then today we go to discussion about this question. Okay, so I think how many here? I go and check attendance first. Wait. Hello, can see or not? Everyone, can you see or not? Please reply me. Okay, wait ah. Okay, I go to recheck back ah. Can see, is it? Okay, I can see the Wen Xuan. Okay, I can see the Jinlu, Jieling, Aini. Okay, so the others. Okay, no more, no guy here. Okay, so we start lah. Ivy also here. Morning, Ivy. Okay, can we start now? Okay, give me the signal. Can we start now? Desmond. Morning. Okay, so we start the lesson. So today we discuss about the tutorial. So I show you the answer first. Okay, so sorry, I go to close. Okay, let's see here. Okay, this one is the objective answer for tutorial 3.4. Please you go to check first. There's a 1 until 16. So from here, if you really do know how to solve the question, that means you can PM me lah. I also will I will teach you how to do the question. Okay, so I still to check your ideal. Okay, ideal come in already. Okay, after that. Okay, some still on the way. Kajet. Okay. Okay, Adrina. Okay, some more. So I do waiting, the rest faster to come in. Okay, so Badru, morning. Okay, I want to show about the slideshow. Hopefully you can see the slideshow. Okay, teacher tak nampak saya ke? Nampak, Fahana. So everyone, okay. Oswald not yet enter. Okay, can see So this one is the answer for 3.4. So you check first 1 until 16. So now I want to go is a structure question. Okay, structure question. This one later you can recall back lah. So now we live already. So I know do the next page. Okay, now let's see the structure question. Okay, question 17. The diagram that show the transformer has the number of the turns, okay, of the primary coil and the secondary coil, 4,000, one is 300. Okay, 4,000 is a primary, 300 is a secondary. So from here, this one is a step down transformer. Okay, now you need to explain how the output voltage is produced. Okay, how we can get the output voltage. Okay, so from here we're going to see how we get the output voltage. Okay, the explanation. Okay, let's see the explanation. Okay, we can see Ko Gian Hong also here. Okay, Chua also in already. Okay, I think got some problem. Can you see my slide? Okay, my slide now is objective tutorial 3.4, is it? Can you see it? Okay, then after that I change the slide already. Sorry, I want to do some correction. Okay, I want to check, is it what you see now? Okay, morning. Okay. Okay, now you see my screen. So I go to try to off this one. So you cannot see. I try to show the slideshow first. I go to wait. You wait me a while. Okay, but the live got a little bit slower. Okay, morning Divya. Okay, you can see this part. So I go to change another slide. See you can see or not. I think got okay. I find it they cannot show lah. So I need to change another thing. Okay, I end first. Later I show you. Okay, wait So later I show you the another one. I go on first. It's okay. Okay, so we just start lah. I think it's low only lah. The rest is okay lah. Okay, everyone. So we start our lesson. Okay, so I need to show my lesson now. Okay, my lesson. Okay, we start now, everyone. So I restart again. Let you see again the live. Okay, so we start the lesson now. So hopefully you can see me. If you got any problem, you can text inside the chat room lah. Also, we take the attendance there. Okay, so we start the lesson by using the PowerPoint. Okay, hopefully the PowerPoint you can see it. Okay, now let's see the PowerPoint here. Okay, so this one is an objective. So hopefully everyone, you just late to enter the chat room. So you can just check the answer lah, 1 until 16. So next I want to show the structure question. Okay, let's see the structure question here. Okay, now the structure question, there's about the number of turns. They show you the transformer. The transformer one is a 4,000 of the turn for the primary coin. Okay, another one is a 300, okay, or for the secondary coin. Okay, now you need to explain. Okay, explain how the output voltage is produced. So from here we need to explain how lah. So we're using the working of the transformer. Okay, what's the working of the transformer now? Okay, let's see the first part. Okay, before that we learned already the working of the transformer. How to produce the current to the secondary coin. So the first part is you need to connect with the alternating current. Okay, you need to connect to the alternating current. I find it here cannot change. Yeah. Okay. So from here you need to see is the slide cannot change, is it? They still show the objective. So now I show the answer already for the second part. You still cannot see. So what can I do? I just show like this lah. So hopefully you can see lah. Okay, I show this part. Although it's small a little bit, but hopefully you can see it. A little bit problem because this one is a Microsoft Office 2019. Okay, I just show this part. Cannot slideshow because they just show one slide only. Another slide they cannot show. Okay, so from here I want to show is this part. Okay, so from here that's the explanation. Okay, explanation how the current will flow to the primary coin. So from here we need to see how the voltage will appear at the secondary coin. So that means you must mention when the alternating current they flow into primary coin. Okay, the soft iron core is magnetized. Okay, they magnetize first. Okay, number two, the magnetic field that will link to the secondary coin when changing of the magnetic flux. Okay, you must say about the changing magnetic flux. Okay, after that they will go to the link to the secondary coin. Okay, last one, the induced EMF you produce. So this one is how we explain. How we go to explain the induced current, or you say the induced EMF, how to go to the secondary coin. Okay, now I go to the second one. Second one is a calculation. Calculate the output voltage of the transformer. Output voltage. So they want to find VS. So from here, because I cannot slide show, so what I can do, I just show you the answer straightforward. Okay, let's see the answer for the second part. Okay, this one. Okay, you can see the answer there. I show already the calculation. Okay, that's a VS we do know, is it? Then the V primary we know 240. Then after that this one is a secondary. Then this one is a primary. Then we need to find is a 18. We find already the secondary voltage, there's a 18 volt. Okay, 18 volt. So this one is a step down transformer. Original is how many second? How many second? How many voltage? The voltage when starting is a 240. Final become 18 volt. So this one is a step down transformer. Okay, we go through to the second question. There's a C. Okay, let's see the question C. Okay, question C, they show you the info. The lamp is how many? 36 watt. Okay, after that the volt is 18 connected across the secondary coin. Okay, the lamp light up. Then after that you need to calculate. Okay, now we need to calculate the current in the secondary coin. Okay, the current in the secondary coin. So secondary coin is this part lah, the lamp one. So we can count by using P equal VI. Okay, 36 is a power. Okay, after that the current we don't know how many is it. Then after that 18 is a volt. then we know the current pass through the, this one is what? Pass through the light. The lamp will light up, there's a 2 ampere. Okay, the next one is number 2, the resistance of the filament bulb. The resistance of the filament bulb. Okay, the filament bulb means the output lah. They ask about resistance. Remember V equal IR. That one is the Ohm's law formula we're using. V equal IR. Then the V for the output is 18. After that 2 is a ampere because we just now find already 2 ampere. Then the R we don't know how many. So from here we find it. The filament bulb resistance is a 9 ohm. Okay, it's a 9 ohm. Okay, we continue with the question efficiency. Okay, efficiency of the transformer when the current in the primary coil is 0.2 ampere. Okay, they want to know efficiency is how many when they provide the current in the primary 0.2. Okay, so we write, you can see here, PO over PI, multiply 100%, that one is the efficiency formula. Okay, how I get 36? 36 is from the just now diagram. Okay, I show you back. They say 36 watt is a lamp, is it? So that means now there's a 36 is the output. Okay, how to find the input? Input is 240. There's a volt multiply the current that give you primary. So I multiply 100%. So finally I get how many? 75%. So this one is the efficiency. Okay, now we're going to see the D. State the two-way, how the energy loss in the transformer, and also suggest the way to reduce. So this one we're talking about factor. Okay, remember the factor. Factor we got resistance loss. Okay, number 2 we got eddy current. Okay, number 3 we got the hysteresis. Okay, number 4 we got the leakage of the magnetic field. So they just want 2 only. How we solve and also what's the problem. So the first one I mentioned here is the eddy current, is the iron core. So how to reduce? We're using the laminate iron core. Okay, another one is a hysteresis problem. So we're using the soft iron core. It can be magnetized and demagnetized easily. So this one is a true problem and how we solve the problem. Okay, then we go to the question 18. Okay, let's see the question 18. Okay, I got here to show you got 3 of the diagram. So I want you to see clear about the 3 diagram. We got circuit X, circuit Z, and also the circuit Y. Okay, so the first round, we're going to check input. Input power, input voltage 240. Every one also is 240, is okay. Okay, then you see the turns. Turns also is a 1200. Every input also the same. Okay, now we're going to see the output. Output power is a different. Can you see the power is a different? Okay, you see the bulb. We got 3 bulb. Then the power should be different. Okay, one more should be the same, should be number of turn, 800. Okay, so this one is what I can see through the 3 diagram. Okay, now both of the transformer, they produce the same output voltage. They say output voltage must be the same. Okay, why become same? Because your input voltage same, number of turn also same. So the output voltage must be the same. So we no need to count one by one. We straightforward to count together because 3 also is the same. So you need to calculate the output voltage. So we're using V secondary, we do know, we put at the top. Okay, down is a primary. Primary is a 240. Okay, after that, this one is a NS, number of turn of secondary, that's a 800. Then over the input, the number of turn is 1200. So I find the VS. So I get it, the secondary volt is a 160 volt. So this one is a step down transformer. 3 also is a step down transformer. Okay, then we continue with the question B. Okay, question B, they say all the bulb light up with the normal brightness when 0.25 ampere flow in the primary coil for every transformer. So now we add the current in already. The current, all circuit is the same, 0.25. Okay, now they want you to measure the input power. Input power sure same for 3 circuit. Because your number of turn same, okay, number of turn not related, because the voltage is the same and current is the same. So we just find one power enough already. So the second question, okay, they ask you about the, the second question they ask you about the power, is it? Okay, sorry, I skipped this question already. So B1. Okay, so from here, I write here the B1, so you refer what I type here. Okay, I need to find my box to type first. Okay, insert. Okay, question number 1. Okay, I type here. Okay, how to find the power? Okay, let's see how to find the power. Okay, P equal VI, is it? We just type, okay, VI. Okay, the following. Okay, we need to find out the answer. So V is how many? 240. 240. Then the current just now they mentioned there's a 0.25. So the final answer for the power is 60 watt. Okay, so this one's the answer for the question B1. Okay, just now is A, this one is a B1. So hopefully you can see clear here. I type ready. Okay, I make it become bold. Okay, I put the box so you can see clear. Where's the box? Okay, you can see about clear the shape. Okay, so this one. Okay, so this one is the answer for the B1. Okay, you can see clear. Okay, so all the power become the same. Now I need to go to the question number 2, B2, output. Okay, power output should be different. Okay, before I go to power output, I'm going to explain first. Okay, let's see the arrangement for the bulb. Arrangement for the bulb, this one is a series. This one is a parallel. This one is a series and parallel. Okay, for the power, we don't care. We no need to see you are parallel or you are series. We just plus only. Okay, so from here you see the circuit X. Circuit X got 3. 3 also is a 12. So this one sure 36 watt. Okay, how about the Z? Z we got 18 times 3. Okay, then the last one is we got 12 times 2 plus 24. So this one we straightforward to find the power. No need do any formula. Okay, straightforward. So from here I show you the answer. PX, power for circuit X, 36. Okay, power for Y. Okay, this one is 12 plus 24 become 48. Okay, the last one is a Z. Z is a 18 times 3 become 54 watt. Okay, so this one is an output power. Okay, now we go through to the following. There's a C. Which one circuit they containing the transformer with the highest efficiency? How to find the highest efficiency? Okay, just now we find the input is a 60 watt, is it? So which one produce the biggest power? The answer sure is a Z. Z is a 54. So that means you lost how many? You just lost 6 watt. So that means the answer C should be circuit Z. Circuit Z, you produce the highest efficiency. Why? Why we say like this? Because they produce greatest output power. So that one is a reason. Okay, then we need to go is the following diagram. Okay, you can check the following diagram. They show you the 4.1 computer battery charger. Okay, connected to the 240 AC power supply. The battery charger consists the box X and also box Y. Okay, one more thing to tell you. Computer, all the thing in your house, actually we using is a direct current. So that means later the alternating current from the transformer, we need to change. Okay, another one you're going to see this one transformer is a step down transformer because 240 is too large. Okay, our appliances cannot support. So from here we need using the step down transformer. Another thing is one more component. They want to reduce, not reduce, they want to convert alternating current to become the direct current. Okay, so from here the first one A, the function of the component in the box X is lower. The voltage 240 become 20 volt. Okay, name the component for the X. So X we know lah, this one is a step down. We go to refer the turns. Okay, the next one. Okay, explain why the AC is not DC supply in 4.1. Why we using AC? Why we cannot using DC? Straightforward, go to computer lah. So the answer is constant. Okay, this one is wrong typing. Okay, we're using the constant magnitude. Okay, so from here, why we using the AC? Let's see the DC. DC voltage produce constant magnitude and direction. Okay, remember this sentence. Okay, I told you already. For the AC, we're using various. For the DC, we're using constant. So they produce a constant magnitude and direction in the soft iron core. So therefore, changing magnetic flux does not happen. Okay, if you don't have any changing magnetic flux, means you cannot have the induced EMF across the secondary coil. So this one is the reason why we're using AC. Then we don't want to using DC. Okay, now number 3, can you state the physics concept which explain how the component in the box X work? Okay, physics concept. Physics concept means we're using principle, electromagnetic induction. Okay, electromagnetic induction. Okay, then B, calculation. The efficiency of the component in the X is 80. Okay, they give you efficiency. Calculate the input current when the output power is 65 watt. Okay, output power already give you 65 watt. That means you need to count the current, okay, from the input power. So we show the question first. Okay, 65 output power. Input voltage we know 240, but the current we don't know. Okay, after that multiply 100%, then they give you efficiency is 80. So what you need to find now, you need to find is input current is how many? So the answer is 0.338 ampere. Okay, hopefully today you take out the paper is for marking, not for copy. Okay, then we need to go is the last one. There's a problem solving 10 marks question. Okay, let's see this one 10 marks question. Okay, 240 input. Okay, AC power supply. Modification has been made the transformer so that the transformer can be used and efficiency 6 volt. Can you see 240 convert to 6 volt? So means we need to using what transformer? Sure is a step down. Okay, mobile phone charger. Mobile phone charger is a direct current. Means later you need to convert alternating current become direct current. So now they ask you, first one, I want to produce 6 volt output voltage. How to produce? So that means later you need to see you using the step down transformer. Okay, why you want to using step down? Because I want to reduce the voltage. Okay, number 2, steady direct current. Later want to produce the steady direct current. How to produce? Okay, this one suppose not in this topic. That should be in the chapter 4. So later I will explain how we convert the AC become DC. Okay, so from question 1 and question 2 actually is a 4 marks only. Okay, all marks is from the number 3. High efficiency. How to increase the high efficiency? So all the factor you can mention now. Okay, can you see the question they're using soft iron core? Okay, when they're using soft iron core, we cannot mention the soft iron core again. So you can say about the eddy current, you're using the laminate. Okay, you also can say you're using the thicker wire. You can reduce the resistance. And the last one, you say you're using the proper shape. You change the shape become the number of turn primary and secondary become closer. So this one is a 3 more point you need to add. Okay, so now we start. Go and see the answer. Okay, first one, use a step down transformer. Okay, use a step down. Then after that, then you say this one to reduce the output voltage. Okay, number 2. Okay, this one I want to explain. Apply the 4 diodes to arrange the bridge rectifier. Later I show you what's a rectifier. Okay, reason I want to convert AC current to DC. Okay, let's see the bridge rectifier and diodes. Okay, this one is a diagram. This one we call bridge rectifier. This one is a transformer. Okay, can you see got 4 diodes? This one is a symbol for diodes. I label for you. 1, 2, 3, 4. Okay, now I want you to check the color of the arrow. Green color arrow. Okay, green color arrow is a 1 cycle. Okay, blue color yellow is another cycle. Okay, so now we start with the green color first. Okay, so now alternating current is it? So I start from here, green color. So the green color current will flow. After that I go to the diodes. Okay, where I need to go? Okay, I need to go is a number 4. Okay, remember this one is a positive. Triangle is a positive. The flat one is a negative. So the current, if I start from here, they must go through the positive first. Okay, they go in the positive through the number 4. Okay, after go this one, I cannot go number 3 because number 3 here is a negative. Okay, I must finish 1 cycle first. So the positive will go here. Okay, now you got junction. Where to go? Okay, follow this one green color arrow. I go to find the load. So this one is a resistance. Okay, then I go here until this. Okay, this part. Okay, can you see the center? We got one of the line. This one actually not junction. This one just overlap. Okay, the upper wire overlap the down wire. Okay, so now they continue to go up. Okay, after go up, they go to number 2 because number 1 you cannot go. Okay, you must go. You cannot. You start from here. You cannot say you back from here. You must back another terminal. So when I go to this part, I go to number 2. Follow the green arrow. I go to number 2. After go to number 2, then I come back. I go here. Then I back to the circle, the green color, another terminal. Okay, so this one is one of the process. So let's see the way how we move. We start from 4, go to the load, then from the 2 I go back. So that means this one is first cycle finish. Okay, so first cycle when I pass through the load, how? One direction is it? From the up come down. Okay, now second cycle. Second cycle I from the blue color arrow. Okay, blue color yellow I come in. Then after that, where I need to go? Okay, blue color yellow I come in. I cannot go to the number 1. Blue color means I go to lower wire. Lower wire. So I just come in. I go here. Okay, now this junction. I cannot go number 2 because number 2 is a terbalik diode. I need to go is number 3. Okay, blue color arrow number 3. Until this junction, I also cannot go to number 4 because number 4 is opposite. I need to go to load. Okay, I still go to load. Okay, how I go to load? I just from the top go down. Okay, from the top I go down. Okay, when I go down, then I go continue until this part. Until this one not junction. This one just overlap. I up. I straight up. I cannot go to number 2. If I go to number 2, that means I go back. Same terminal. I must go to number 1. Blue color. Then I up. Then I go back. So now the pathway for the second blue color arrow is from the 3. Go to load. Then go to 1. Okay, finally I want to check is how the direction, how the direction of the current pass through the load, how the direction they pass through the road. So that means I want to see, is it the resistor, this one resistance, direction they pass through the road always the same. They from the here, and they come down. Green color also from this part to come down. So that means overall, I just want to say, this whole thing they produce is a direct current, because they move this one from the top go down. That means they never change about the direction when they pass through the load. So from here, how to detect? We just want to detect the load only. The rest I don't want to see. So finally, they produce is a direct current. Okay, they produce is a direct current. Okay, so everyone, you understand or not? This one I will continue to repeat for the following topic lah, because this one not the exactly we need to explain. Okay, exactly we need to explain is the next topic, that's the electronics. So this one just introduction lah. So this one diagram, we call it as a bridge rectifier. Okay, bridge rectifier built by 4 diodes, or 4 diode arrangement. Okay, so we continue with this one. Okay, efficiency. How to increase efficiency? Laminate the iron core to reduce the eddy current. Okay, use the thick copper wire to reduce the resistance. And the last one, winding the secondary and also primary coil on the top and each other. So this one, right, we can reduce the leakage of the magnetic flux. Okay, so understand, this one is an AC question, how to build the transformer. Okay, so our lesson just until here only. So hopefully you will understand what I'm talking about. Then I'm very, very sorry when starting because some technician problem. So the coming is I think next week lah. No, next week, tomorrow class, is it? Tomorrow class I want to give the exercise lah, some of the exercise for this 3.4. Okay, some exercise for 3.4, maybe the Google form, you just go there to answer it. So our lesson just until here. So attendance, make sure the attendance is here. I'm going to check first. Okay, some never write the attendance, so I never jot down your name. So hopefully, okay, now it's about time, 10:20. Okay, so our lesson just until here lah. Thank you for your watching. Okay, everyone.